Hello everyone, how are you all? I hope that all of you are doing amazingly great. Today I will discuss about function. We'll learn in depth about function. Okay, to know about this function, you must concept of relation. What is relation? Do you know what is relation? To know relation, you can follow my previous video in the description box. Okay. Function is a special type of relation. Function is a relation defined from set A to B such that all elements of the set A related to only one element in the set B. Okay. Mathematically, we can denote function A maps A to B. Hit A and B to non-empty set. Okay. In other words, we can say that let A and B to non-empty set. Okay. A function is a rule that assign all elements of A in the set. All elements of A must define A element of B. Okay. Here, A is a set which contains 1, 2, 3, 4 elements, and B is the set which contains 5, 8, 10, 12. Here, A set is called domain set and B is the called codomain set. Okay, this is domain set and this is codomain set. One is the image set of image 5. My image 1, 2 is 8, and image of 3 is -10, and image of 4 is 12. Okay. Similarly, pre-image of 5 is 1, pre-image of 8 is 2, pre-image of -10 is equal to 3, and pre-image of 12 is equal to 4. Okay. Now, is this a function? Yes, this is a function because here we use every input. We use every input like 1, 2, 3, 4. Every input we use, and we can get only one output. The output of 1 is only 5. Output of 2 is only 8. And output of 3 is only -10. And output of 4 is only 12. So, this is a function. You must remember 2 points. We use every input and we get unique output. You cannot get multiple output. Okay. Next, we'll discuss many functions with an example. Okay. Now, you will see this example. Okay. Here, it set is contains 1, 2, 3, 4 elements, and B set contains 1, 4, 9, 16, 25. Is this a function? Yes or not? Here, we can see that each element of A must assigned to be set B. 1 assigned to 1, 2 assigned to 4, 3 assigned to 9, and 4 assigned to 16. Okay. So, this is a function. Okay. If we see that 3 elements is not assigned to in element B, in the set B. Okay. 0 assigned to 2, 1 has the image 3, 2 has image 3, but 3 has no image. Okay. So, this is not a function. Okay. Here we see that 1 has image A, 2 has image B, 2 has image C. You must remember this. 2 has image B and 2 has image C. So, we can get multiple output. and we say that we cannot have multiple output. So this is not a function. Yes, am I clear? Okay. Now we will discuss types of function. Very easily you can understand the function is like a calculator. Okay. There are in the calculator there are many things. If you put 2 plus 5 plus 3, then you get 10. Okay, you cannot get multiple answer. So this is a function. Now we will discuss the types of function. First of all, injective or one-to-one function. Why a function or mapping is said to be injective. Okay, a mapping or function or transformation, if maps A to B, is said to be injective or one-to-one. If pair of each distinct element of A, their image are distinct. You follow this. Otherwise, it is called many-on function. You must follow this function. Set A and the codomain set is B. Here 1 image 1, 2 maps 4, 3 maps 9, 4 maps 16. Distinct elements and image are distinct. Okay. So this is one-to-one or injective function. Okay. You can see this function. Hey, A maps X, B maps Y, C also maps Y. Okay. Must be follow this. B maps Y, C map also maps Y. Here 2 elements maps 1 element. Many elements maps 1 element. So this is example of many-on function. Okay, am I right? Okay. Now we will discuss next types of function, surjective. Okay. Now we will discuss about surjective function. What is surjective function? Okay. A mapping or transformation or function, if maps A to B, is said to be surjective or one-to-one, if f of A is equal to B. That is, the range set and the codomain set must be equal. Okay. Otherwise, we can say that every elements of B might have pre-image. Okay. For example, suppose this is an example of function. Here we see that 1 maps A, 2 maps B, 3 maps C, and 4 maps D. You see that every elements of B has pre-image. Okay. So this is an surjective function. This is a example of surjective function. Okay. Here we see that 1 maps X, 2 maps X, 3 maps Y, 4 maps Z, but here the elements W has no pre-image inside B. Okay. W has no pre-image inside B. So this is not a surjective function. This is function but not a surjective function. Okay. Now we discuss an important types of function, biject. When a function is said to be biject, if function f maps A to B is said to be bijective function if it is injective as well as surjective. Okay, then we can say that this is the example of bijective function. This is the bijective function. Okay. Next, we shall discuss about one-to function. Into function. So, when a function is said to be into function, okay, if mapping or function, if maps A to B is said to be an into function, if f of A, that is range set, okay, is proper subset of B, okay, proper subset of B, must remember this. For example, set A contains 4 elements and set B contains 5 elements. Here A is domain and B is codomain. We notice that the range set is f of A is the set of 2, 5, 10, 15. 1 maps 2, 2 maps 5, 3 maps 10 and 4 maps 5. So, the range set f of A is the collection of image set, okay? 2, 5, 10 and 15. But domain codomain set means 2, 5, 10, 15 and 20. You notice this f of A is proper subset of B, okay? So, this is an example of into function. Is it clear? Okay. Next, we will discuss about this thing by using a mind map. Okay. Now, we will discuss various type of function by using mind map. First of all, function. Let A and B to non-empty set. Function F maps a function F maps A to B. A function F maps A to B is a rule that assign each elements of A has unique element or unique element in B. Okay. Types of function are many, such as injective, surjective, into function, manual function, bijective function. Injective function, first of all, injective function. A function F maps A to B is said to be injective function if each pair of distinct elements we can get a distinct element, distinct image. Okay. Mathematically, you can state that we can state that f of x1 does not equal to f of x2 must imply x1 does not equal to x2. Or if f of x1 is equal to f of x2, this must implies x1 is equal to x2. That is, if image sets are unique, then elements are unique. Or elements are distinct, then image must be distinct. Okay. Next, surjective. If maps A to B is said to be surjective for 1 to 1 if f of is equal to B. Okay. That is, the range set and the codomain set are same. Okay. Or otherwise, every elements of B must have pre-image set. Okay. Whole function is said to be bijective. A function or a mapping F maps A to B is said to be bijective if it is injective as well as surjective. Okay. We said a function is manual. A function is said to be manual function where many elements of A assigned to one elements of B. Okay. Next, into function. A mapping F maps A to B is said to be into function or mapping if f of A is proper subset of B. That is, range set is proper subset of codomain set. Okay. That's all today. We will meet again in our next video. Thank you everyone. Well done.